Hello, good evening. I want to look again at how the laws of indices might be practically used. One of the things I find, is that, if I can just tidy up, most textbooks in trying to explain the laws of indices, and most teachers in trying to explain the laws of indices, use algebra, which is fine in its way. But they'll use something like maybe m to the power of n equals etc. and so on. I have found in my experience that although we don't mind using a letter sometimes, we want to use a mixture of letters and numbers so that the student can see what is going on. Let's just use numbers initially. Let's, for an example, give this. I don't need to write down the laws of indices. You will be able to see from what I'm doing what the laws are. So we might have 2 to the power of 5, and that is times 2 to the power of 6. Well, 2 to the power of 5 is actually a multiplication, and this is another multiplication. And therefore, and obviously 2 to the power of 6 is a multiplication. It's 2 times 2 times 2, and etc. And so all we need to do really is to add the 5 and the 6. The base 2 remains the same. This is called the base, this number here. So this becomes 2 to the power of 11. All we're doing is adding these two values together. Now, what is important to know is that 5 is not the number of times that the 2 is multiplied by itself. It is actually the number of 2's that are in the expression. So there's 2 times 2 times 2 times 2 times 2. So 5 2's, and there's only 4 multiplication signs. But 2 to the power of 5 times 2 to the power of 6, all we do is add the powers. So therefore, looking at it carefully, it is 2 to the power of 5 plus 6. And that remains the same. And the way I remember it, I suppose, really, is that 2 times 2 is going to be a higher number than 2, and 5 plus 6 is going to be a higher number than 5 and 6. So when you're talking about multiplication, both numbers are going to go up. What's the antithesis of multiplication? Well, we have, let's just do another version of this to start off with. Let's say a times a squared times a to the power of 5. Well, what are we actually saying? What power is this one to? Well, a to the power of 0 is 1, so it's not a. So this must be a to the power of 1. A on its own is a to the power of 1. And we're going to add. Now, the a's don't multiply at all because we're not talking about a cubed here. We're just talking about a is the base of the term in the expression. So we're going to have, this is a to the power of 1 plus 2 plus 5 equals a to the power of 8. All we're doing is, if the base is the same, then we leave that alone, and we just add the powers. This one's not shown, but we're assuming that a itself is the power of 1, because a to the power of 0 is itself 1, and therefore this must be to the power of 1. Now we're going to introduce division. This is all multiplication. So we look at division. We might have a to the power of 8 divided by n to the power of 8 divided by n to the power of 5. Now in this particular case, as in multiplication we added, with division we subtract. So this becomes n to the power of 8, this 8 here, minus 5, which equals n to the power, or n cubed, n to the power of 3, n cubed. So rather than using completely algebra, we're now using numbers as the powers, and we can see what we're doing. Let's have another a look at another example. Let's say, for instance, we had 10 to the power of 5 times 10 to the power of 3 divided by, we're combining now these two laws, 10 to the power of 4. Now, therefore, we're looking at 5 plus 3 equals 10 to the power of 5 plus 3 and it's divided by 4, so both of those minus 4, which equals 10 to the power of 4. And that's the right answer. So here we're combining the use of multiplication. I've put a times there, multiplication with division, and therefore we're adding these two and we're subtracting that from the answer. So we've got 5 plus 3 is 8, minus 4 is 4, and that's the right answer. Let's have a look at similar. Now, what we've got here, of course, what we haven't dealt with yet, and I'm using these, all of these are examples. We've combined multiplying by dividing. We're now going to combine positive powers with negative powers. So let's suppose we had z to the power of 4 times z squared times, still times, not divide, times z to the power of minus 3. Now what we've got here therefore is, now the point is that we're going to add, this is minus 3, and we're going to add minus 3, if that makes sense. So we end up in this case with equals z4 plus, sorry, this is, I'm talking about the powers being plus 2 plus, yes, because this was still multiplied by, yes, so it must be plus, but it's plus what? It's plus minus 3. So if you don't mind me putting that like that, and then we end up with z to the power of 6, 4 plus 2, minus 3 equals z cubed. Now you see what we did? This was division here, but this is actually division as well, but we're multiplying, so we use the same rules as we use for multiplication as we did here. Alright, so this is actually z to the power of, 1 over z cubed. So just keep looking at it, we're doing fine. Let's move on. Let's have another look at the fact that we might be dealing with powers that involve fractions. So let's say we had m to the power of 5 times m to the power of 6 divided by m to the power of 4 times m to the power of 3. Okay, well the same rules applies. This is add these two powers as we did here. So we've got m. We're not actually multiplying m by m. Because m is to the power of 5, it's m times itself 4 times. And what we've got here is m to the power of 11. 5 and 6 is 11. And underneath, so we put that, we'll continue with the fraction, m to the power of 4, and this is added, because multiplied. These are, m to the power of 4 is a multiplication, m to the power of 3 is a multiplication, so therefore we just add the multipliers, and therefore we have m to the power of 7. And that equals, now, when we're dividing by a power, we end up subtracting the power, as we did here. So we end up with m to the power of 11 minus 7 equals m to the power of 4. And that's the right answer for all of this. That boils down. So what we've done here is we've added, and then we ended up with a fraction, and therefore we have subtracted the top one from the bottom one. In terms of powers, m remains the same. Forget m. Doesn't matter what the value of m, the value of m is. It doesn't matter. What we're doing is to just apply the rules of indices to solve the problem. So that becomes m to the power of 4. Let's have a look at another way of looking at this thing. Let's have x squared times x divided by x to the power of 6. I hope you can see this. Now, what is this? Well, if we've got x, these are both the same base, so we've got x. Now, what isn't written here, which you are expected to assume, is that this is x to the power of 1. And therefore, we add these two, so we've got x to the power of 3 over x to the power of 6. Which equals, because we're going to bring this up, it becomes x to the power of 3 minus 6 and that equals x to the power of minus 3. All we're doing now is combining the laws. I didn't express the laws initially because you don't need to keep referring back to them. It's probably, in my opinion, better just to look at examples. Maybe we should look at some examples of brackets now. We haven't looked at any brackets now. So supposing we've got t times t cubed, and the whole thing to the power of 2. Well, this is t to the power of 1, which is not written, but it's there, it's implied. So this is t to the power of 4. 1, I'm writing it in now, but it wasn't there before. 1 plus 3 is 4t to the power of 4. And that bracket is squared. Now, okay, so what we need to do now is that because this is a multiplication and that's a multiplication, we're going to multiply these two. Up here, we added them. Down here, we subtracted them. And now we're going to actually multiply them. So we end up with t to the power of 4 times 2 equals 8. So far, so good. Now we're coming into another realm where we have, let's have a look. Now, I think I'll stop there and I'll carry on with the part 2 of this video next to this. Please click on like if you do like, on subscribe for future videos and present videos, and please comment or ask questions. Thank you. Good night.